Christian from Graphical College of Agriculture Sciences and Technology. For this video, we have a tutorial on how to solve LP model using graphical method. Before we start on solving, we will discuss first what is linear programming. Linear programming is a method of optimizing operations with some constraints. The main objective of linear programming is to maximize and minimize the numerical value. I prepared one example of a problem solving. Our neighbor was owned a sewing company. One day, she made two designs of dress X and Y. Has the following materials available: 18 square meters for cotton, 10 square meters of polyester, and 24 hours of finishing. The design X requires 3 meters squared of cotton and 2 hours of finishing the dress. Design Y requires 1 meter squared of cotton, 2 meters squared of polyester, and 3 hours for finishing the dress. Moreover, she wants to sell the dress, the design X, for 450 pesos and the dress, the design Y, for 520 pesos. Before we move on solving, we need to make a table. So we have dress, cotton, polyester, finishing labor, and profit. For X, we have 3 meters squared cotton, 0 for polyester, 2 hours for finishing labor, and the profit of 450 pesos. And for dress Y, we have 1 meter squared for cotton, 2 meters squared for polyester, and 3 hours finishing labor, and profit of 520 pesos. We will solve the maximize. So we have 18 meters squared cotton, 10 meters squared for polyester, and we have 24 hours finishing labor. We have two variables, X and Y. The profit function is 450X plus 520Y. And the constraints, we have 3X plus Y greater than or equal to 18. We base this in the table that we made. This is the line of cotton. And then for polyester, we have 2Y greater than or equal to 10. And finishing labor, we have 2X plus 3Y greater than or equal to 24. And our variables X and Y less than or equal to 0. So for solving and to get our points in a graphic, for our graph, we let X is equal to 0 in every constraint that we made. So 3X plus Y is greater than or equal to 18. So let X is equal to 0. So 3 times 0 plus Y is greater than or equal to 18. So the remaining is Y is greater than or equal to 18. Then let Y is equal to 0. 3X plus 0 greater than or equal to 18. The remaining is 3X greater than or equal to 18. To remove 3, we need to divide both sides by 3. So 3X over 3 greater than or equal to 18 over 3. So the answer is X greater than or equal to 6. So for 3X plus Y greater than or equal to 18, we have the points 0, 18, and 6, 0. Then for our polyester, we have 2Y greater than or equal to 10. So we let X is equal to 0. So 2Y greater than or equal to 10. We remove 2 by dividing both sides by 2. So 2Y over 2 greater than or equal to 10 over 2. So So the answer is y greater than or equal to 5. Then we left y is equal to 0. So 2y greater than or equal to 10. So 2 times 0 greater than or equal to 10. So we don't have x, so the answer is 0. So for 2y greater than or equal to 10, our points are 0 and 5 and 0 and 0. So the last one, which is finishing labor, we have 2x plus 3y greater than or equal to 24. So we left x is equal to 0. 2 times 0 plus 3y greater than or equal to 24. So the remaining is 3y greater than or equal to 24. So to remove 3, we need to divide both sides by 3. So 3y over 3 greater than or equal to 24 over 3. So the answer is y greater than or equal to 8. Then left y is equal to 0. So 2x plus 3 times 0 greater than or equal to 24. So the answer is 2x greater than or equal to 24. So to remove 2, we need to divide both sides by 2. So 2x over 2 greater than or equal to 24 over 2. So the answer is x greater than or equal to 12. So our points for finishing labor is 0, 8 and 12, 0. So we have to graph. This is our graph. So we have a points 0, 18 and 6 and 0. So we plot this. And then 0, 5 and 0, 0. So we have a straight line for 0 and 5. And then next is 0, 8 and 12 and 0. So we got this, and this visible region, as you can see, these are the possible points that we get. We will solve the last point, which is from the polyester, which is 2y greater than or equal to 10. Then we left x is equal to 0. So 2y is greater than or equal to 10. Divide both sides by 2. So 2y over 2 greater than or equal to 10 over 2. So we come up the solution, which is y is equal to 5. And then we substitute the value of y, which is 5, to the equation of cotton, which is 3x plus y greater than or equal to 18. So we come up 3x plus 5 greater than or equal to 18. So 3x greater than or equal to 18, and then we move positive 5 to the other side. So we have negative 5. So 3x is greater than or equal to 18 minus 5 is equal to 13. So we divide both sides by 3 to remove the 3 beside the x. So 3x over 3 greater than or equal to 13 over 3. So we come up that the value of x is equal to 4.3333 and so on. We substitute for the profit function, which is 450x plus 520y. The value that we get from the equation of polyester and the equation of cotton. So we have 2p of 0 and 5 is equal to 450 times 0 plus 520 times 5 is equal to 0 plus 2,600. So we come up that the result is 2,600. Then the other one is the value of x and y that we solve. We have p of f.3 and 5 is equal to 450 times 4.3 plus 520 times 5 is equals to 1,950 plus 2,600 is equals to 4,550. Then the last point is P of 6 and 0 is equals to 450 times 6 plus 520 times 0 is equals to 2,700 plus 0 is equals to 2,700. As we can see that our problem is maximized, so we conclude that P of 4.3 and 5 is our highest value, which is become 4,550. So therefore, the best choice is to make 4 dress that design X and make 5 dress that has design Y in order to maximize the sale. This will now be the optimal solution since 4.3 and 5 gives highest value of 4,550 pesos. And that's all